In nature, survival is often a game of shadows and illusions. We are familiar with the classic examples of deception. The harmless hoverfly that wears the vibrant warning colors of the deadly wasp, the orchid mantis waiting to catch a meal, or the stick insect that disappears entirely against a backdrop of twigs. These strategies are collectively known as mimicry, the evolutionary art of imitating another organism to avoid a predator, secure a meal, or simply live to see another day. But in the hidden subterranean world of insects, mimicry undergoes a radical transformation. It moves beyond simple colors and shapes and enters the realm of psychological and social warfare. There are species that don't just copy an individual's appearance, they copy entire societies. They don't just hide in the shadows, they hide in plain sight, protected by the very creatures they are exploiting. This is the world of Wasmannian Mimicry. Named after the pioneering Austrian entomologist and Jesuit priest Erich Wasmann, who first catalogued over 1,000 ant-associated species in the late 19th century, this phenomenon represents one of the most sophisticated forms of biological deception ever discovered. Wasmann was a visionary who realized that certain arthropods aren't just living near ants. They had developed the ability to deceive the entire colony. To understand Wasmannian mimicry, we have to stop thinking about insects as individuals and start thinking about the superorganism. An ant or termite colony is a massive, complex social machine with high-tech recognition systems. They use chemicals, vibrations, and touch to identify friend from foe. To infiltrate such a society, a mimic cannot just look like an ant. It must speak their language, smell like their sisters, and act like a loyal member of the family. This isn't just mimicry, it's a full-scale social infiltration. This creates a fascinating evolutionary paradox. In a world governed by survival of the fittest, a colony of thousands of highly aggressive, well-armed soldiers should be able to identify and kill an intruder instantly. Wasmannian mimics typically offer absolutely no benefit to their hosts. In fact, they are often destructive, consuming the colony's valuable brood or stealing their hard-earned food. Yet, through millions of years of selections, these imposters have found the cheat codes to the colony's security system. By combining visual, tactile, and chemical deception, they have forced the superorganism to accommodate them, feed them, and protect them as if they were royalty. The most iconic examples of this mastery are found among Rove beetles, specifically the subfamily Alerocarinae. This group is a masterpiece of evolutionary radiation, containing thousands of species that have turned mimicophily into a highly specialized career. These beetles have undergone one of the most dramatic biological transformations in the insect world. Imagine a free-living predatory insect that, over millions of years, has been completely reshaped into the image of its host. This mimicoid transformation is so precise that even expert entomologists struggle to tell the beetle from the ant without a microscope. Their bodies become elongated, their waists constricted to mimic the ant's petiole, and their legs modified to match the movement patterns of the colony. Some species even evolve physiogastry, where the abdomen swells to resemble the look of a food-carrying or brood-tending ant. But morphology is just the first layer of the lie. The real secret lies in their behavior and chemistry. These beetles don't just walk like ants. They engage in reciprocal grooming. They approach workers and ask to be cleaned, a behavior that reinforces social bonds within the colony. By participating in these rituals, the beetle effectively launders its identity, ensuring that the colony's defense response is never triggered. Genetic analysis shows that this specific body plan has evolved independently at least 12 different times within this one subfamily alone. This tells us that the ant-like form is an incredible, powerful evolutionary sweet spot. Once a beetle enters the world of an ant colony, the pressure to conform is so intense that nature keeps arriving at the same solution over and over again. However, if you want to see the absolute apex of this deception, we have to look at the singing deceivers, the butterflies of the genus Phangarus. known as the large blue and Alcon blue butterflies. Their story is a multimodal masterpiece of infiltration. Most butterflies spend their lives on plants, but fingerless butterflies spend up to 2 years of their life inside the dark, dangerous heart of a mimica ant nest, surrounded by thousands of potential killers, gaining over 95% of their body mass by either eating the ant larvae or being fed directly by the workers. The infiltration happens in two distinct stages. The first is the pre-adoption phase. Female butterflies lay eggs on a specific plant species, and early larvae feed phytophagously on these plants through the first 3 instars, acquiring less than 2% of their ultimate biomass in this phase. Upon reaching the 4th and final instar, the caterpillar abandons the plant, falls to the ground, and it begins to release a chemical cocktail that mimics the pheromones of ant larvae. To a foraging ant worker, this caterpillar doesn't look like a meal. It looks like a lost sister that has fallen out of the nest. The ant's instinct to protect the brood is so strong that it picks up the impostor and carries it into the deepest, most protected chambers of the colony. Once inside, the post-adoption phase begins. The caterpillar begins to refine its chemical signature, matching the specific scent of that individual colony. But then, it does something even more incredible. It starts to sing. Researchers have discovered that ant queens produce a specific vibration, or stridulation, that signals their high status to the workers. When fingerless caterpillars are inside the nest, they mimic the acoustic signature of the queen. When the caterpillar sings, the worker ants treat it with the highest level of reverence. During a crisis, for example, if the nest is disturbed or attacked, the workers will actually rescue the parasitic caterpillar before they rescue their own legitimate larvae. By hacking both the chemical and acoustic communication channels of the colony, the butterfly elevates itself to the status of royalty, ensuring it is the first to be fed and the first to be protected. But ants are not the only ones being fooled. Termites, despite being quite different from ants biologically, are also victims of high-level social parasites. In the anti-Atlas Mountains of Morocco, scientists recently discovered a species of blowfly larvae from the genus Rincomia that has achieved a level of integration that seems physically impossible. In the pitch-black subterranean world of a termite nest, eyes are useless. Termites recognize each other through touch and smell. The blowfly larvae have evolved a posterior end that looks exactly like a termite head. The breathing holes, or spiracles, have been modified to look like the termite's simple eyes, or ocelli. They even have sensory appendages that imitate termite antennae. When a termite approaches the fly larva from behind, it feels what it thinks is another termite's head. This tactile deception is backed up by a perfect chemical match. Each termite colony has a unique chemical passport, and anyone without it is killed instantly. Yet, these fly larvae manage to match the chemical signature of their specific host colony perfectly. If you take a larva from one colony and put it in another, the termites would kill it. This means the fly larvae are either incredibly fast learners or they are literally stealing the scent from the enemies. They are so well integrated that the termites groom and feed them, completely unaware that they are raising a fly in their midst. Researchers hypothesized that adult blowflies lay their eggs around termite nests and the newly hatched larvae are adopted by workers, just like the fingerless genus. Though the complete life history remains unknown, only 5 larvae were collected across 2 expeditions, despite intensive searching, suggesting this represents an exceptionally rare evolutionary innovation. Perhaps the most real example of Wasmannian mimicry isn't even an animal, it's a fungus. The cuckoo fungus produces small, hard structures called sclerotia that are known as termite balls. These fungal spheres are the exact same size, shape, and texture as termite eggs, but the deception goes deeper than just touch. The fungus actually produces a specific enzyme called beta-glucosidase. the same enzyme that termites use to identify their own eggs. The termites are so truly deceived that they gather these termite balls and store them in the brood chamber, cleaning and protecting them from pathogens. In a hive colony, the fungus stay dormant, enjoying the protection of the termites. But if the colony becomes weak or the workers are removed, the fungus reveals its true nature, germinating and consuming the very termite eggs it was mimicking. It is a biological Trojan horse, waiting for the perfect moment to strike. Back to the animal kingdom, some mimics have evolved puppets to do the dirty work. In Australia, there is a species of Rove beetle that has taken morphological mimicry to a bizarre extreme. It grows a structure on its back that looks exactly like a termite. This isn't just a vague resemblance. It has segments, fake legs, and fake antennae. The beetle presents this living puppet to the host termites. The termites, seeing what they think is a hungry nestmate, begin to feed the structure, providing the beetle with a constant supply of pre-digested foods. A similar case in Southern Africa involves another beetle. Its body is a masterpiece of destruction. The beetle's actual head and thorax are tiny and hidden, while its abdomen is massive and folded over its back to create the silhouette of a termite. From above, it is a perfect match. From the side, it looks like a twisted balloon, but in the dark, crowded tunnels of a termite mound, the silhouette and the chemical scent are all that matter. This beetle lives a life of total luxury, sheltered by a species that would otherwise kill it on sight. What we learn from these diverse examples is that Wasmannian mimicry is a multimodal strategy. These mimics exploit every sense their hosts have. If a beetle is a poor visual match, it compensates by being a perfect chemical match. If a caterpillar is a chemical stranger, it uses sounds to force the ants into submission. This redundancy makes the deception robust. It creates an evolutionary arms race, where the hosts are constantly trying to upgrade the security, and the mimics are constantly finding new backdoors into the system. This isn't a new trick either. The fossil record shows us that this game of social deception has been going on for nearly 100 million years. In Burmese amber, dating back to the Cretaceous period, we have found Rove beetles trapped, alongside the very termites they were parasitizing. Even while dinosaurs walked the earth, these tiny hackers were already perfecting the art of the social lie. The fact that this strategy has persisted for so long and evolved independently so many times proves that the colony is one of the most profitable environments for a parasite to exploit. As we look closer at the world of arthropods, we realize that the line between individual and colony is much blurrier than we thought. Wasmannian mimicry reminds us that evolution doesn't just build faster legs or sharper teeth, it builds better layers. It creates creatures that can navigate the most complex social structures on Earth by turning the host's own biology against itself. It is a testament of the incredible ingenuity of life, where a beetle can become an ant, a fly can become a termite, and a fungus can steal the identity of an egg. I hope you all enjoyed this tour into the world of social deception. This is my very first video for this channel, and I promise you there is a lot more to come. We're going to talk about parasite crustaceans, virus-loaded wasps, how a little mite is changing our perception about the limits of evolution, and many more. The world of arthropods is full of wonders, and we've just scratched the surface. Please let me know in the comments what you think about Wasmannian mimicry. Does it creep you out, or do you find it as fascinating as I do? Also, if you have any ideas for future videos or specific animals you want to see covered, leave them below. I'll be checking the comments and using your suggestions to shape the next few scripts. I've left links to the academic papers and recommended readings I used to research this video in the description for those who want to geek out on the science. Thank you for watching, and I'll see you in the next tour.